Good morning, geometry students. Welcome to another lesson. This is 11.3, and today we're going to be working on something called the geometric mean. Mean usually means it has the idea of being an average, and so this time what we're going to be working on is what happens when you have a pair of x's across the proportion. Let's work on this proportion the same way we normally would. If we were to cross multiply, we'd get x times x is x squared. And if we were to multiply the other direction, we get x squared equals 81. Well, then we can simply take the square root of both sides, and we'll get x equals positive or negative 9. Honestly, if x is the geometric mean of values of a triangle, we're not going to be looking for the negative value, so we'll go with positive 9 as the solution. So it's a pretty simple concept. Where this gets a little bit tricky, and where I'd like to help you out today, is what happens when you have the altitude of a right triangle that creates three similar triangles. So here I've got a diagram for you in which we have three similar right triangles contained within one right triangle based on the altitude. And so what I'd like to do is I'd like to get out my highlighter, and I'm going to highlight the three similar triangles that we have. So try and make this as easy as possible for everybody. So you can see the green triangle. We're going to call that the medium-sized triangle. And then I'm going to have a blue triangle here. Which is right here. And then we have our large triangle. So we have our small triangle, our medium triangle, and our large triangle. Large triangle I'm going to highlight with red on the outside. So again, it creates three similar triangles. And these three similar triangles you're going to see when we finish things up is going to create a geometric mean. So we have 1, 2, 3 triangles. Now, with each of these three triangles, there's a small side. There's the longer leg, which we'll call the medium side, and there's the hypotenuse, which we will call the long. So there's the small side, the medium side, and the long side. The two legs are the small and medium, and the hypotenuse is the large. Kind of exaggerate this diagram, make it really long right triangles in order for you to really visualize what we're talking about. And here in the green triangle, we have the small leg, and then we got the medium leg, and we got the largest side being the hypotenuse. And then in the red triangle, we have the small leg, we have the medium-sized leg, and we have the longest side of the triangle, the hypotenuse, which we'll just call L for that. So now what I want to do is I want to sketch out the three triangles. They are similar triangles. According to this lesson, the altitude of a right triangle creates three similar right triangles. Now, in the red one, there's the small side. We don't know the small side, so I'm just going to write SM for that small side. And then we have a medium side. Again, we don't know the value of that medium side, but we do know the value of the longest side. The value of the longest side is 80 units. So there we go. That's the red one. And now I'm going to make the medium one. Which will look something like that. And the small side of that is called X. You can see right here, I got that. The small side is X. The medium side, I get that from right there, is 65. And the longest side, the hypotenuse, I don't know, so we'll just call that L. Okay? Now, you'll notice that L here is the same thing as the medium side here. So on some other diagram, you might want to call that like another value like y. Then we have a small triangle. A little triangle right there. And all I did was I took that triangle and like I laid it down on the side so they all look the same. You can see there, let me just kind of write this, excuse me. There is a right angle right there, which should help us. The small side, see from right here, is 15. The medium side, you'll see from right here, is x. And we don't know the longest side, but you'll notice that the longest side of this blue guy is the same as the smallest side of that hypotenuse, all right? So now you say, okay, Mr. Wilson, how does this set up a geometric mean? Well, what I'd like to do is I'd like to focus on these two triangles. Now, some problems you might want to work on a different set or a different pair of triangles, but this time I want to work on this set because remember they are proportional. So we're going to say the pre-image, the image over the pre-image. We're going to make the larger one the image. So we got the image over the pre-image, and we're going to set that up as a proportion, okay? So what I have is in the image, I have 65 is to the pre-image x, as in the image right here, x, excuse me, x in the image, so I got that from right there, is proportional to the pre-image's 15. I hope you see how I got that. I got 65 over x is proportional to x over 15. Same thing that we were doing yesterday. Now what I want to do is you can see that this creates a geometric mean. Let me highlight the geometric mean to you because there's an x in one denominator and x in the numerator that creates a geometric mean. Now let's cross multiply. We'll have 65 times 15 equals x times x, which is x squared. So again, 65 times 15 equals 975 equals x squared. Then we take the square root of both sides and we can reduce that to 5 root 39 equals x. Or you could have, I would have been fine with x equals the square root of 975. I would have even accepted x equals approximately 31.224. This is the most exact simplified answer, and this is the approximate answer, okay? And again, I accept both of those. I know you maybe you haven't spent a lot of time rationalizing radicals. That's okay. We'll keep moving on. Here's another geometric mean, a different type of geometric mean. You can see here that there's a 2 and a 2, which causes this to be a geometric mean. And so we'll do the same thing that we did on the last slide, and we're going to cross multiply. So we're going to get x times x minus 3 equals 2 times 2. Not 22. 2 times 2. Okay, so again I cross multiplied the 2 and I cross multiplied the x. So now we'll distribute the x on the left hand side, x squared minus 3x. Then we'll multiply 2 by 2 to get 4 on the other side. Now this is something that we've seen this year. I know you didn't spend a lot of time doing it. Again, this is something that you should have conquered in Algebra 1. And I'm going to show you again how this is done. This is called a trinomial concept from Algebra 1 that carries over. Math always carries over. So you want to build this. This is something that you want to stick into your repertoire. It's one of the arrows that you want to have in your mathematical quiver. And so in solving a trinomial, there's actually a number of ways to solve a trinomial. The easiest is with something called factoring. And this lends itself to factoring. So we have x squared minus 3x equals 4. And we're going to set that equal to 0. The majority of the time when solving a trinomial, the easiest thing to do is to set it equal to 0. And we're going to try something called factoring. You can also use something called the quadratic equation and completing the square. However, the only method I've taught you in geometry class is factoring. In algebra classes, you will use also completing the square and the quadratic equation. So we'll set this up as a set of parentheses, and then we're going to look for the signs, and if this sign is negative, then your signs are guaranteed to be positive and negative. One of them will be positive, one of them will be negative. Your variables are going to be x. X is at the front of this trinomial, and so our variables will be x at the front of this trinomial. Now I'm looking for two numbers that are factors of 4. So if I think about factors of 4, you could have 1 times 4 or 2 times 2. So their product must be 4, and their sum, or their product should be negative 4, and their sum should be negative 3. Or if we looked at the absolute values, we'd say the difference should be negative 3. And remember, one of these is going to be positive and one of these is going to be negative. So you can see 2 times 2 will give you a product of 4, and 1 times 4 would give you a product of 4. But what about if we had the sum and we want to get negative 3? Well, think about it. 2 plus a negative 2 would be, their sum would be 0. And the sum, or actually if you took the absolute value, the difference of these, if you had a negative 4 there, plus 1, the sum would be negative 3. So again, you're going to put in those factors right here, negative 4 and positive 1. Now we want to know what x equals. And there's something, again, this is something we've talked about already this year. The 0 rule of factors states that this should be x plus 1 can equal 0, or x minus 4 can equal 0. Well, when would x plus 1 equal 0? When x is negative 1. And when would x minus 4 equal 0? Well, if you added 4 to the other side, you get x equals 4. So there are two possible solutions to this question. I don't know that this is part of a triangle, so we'll say that it could be negative 1 or positive 4 would both make this geometric mean work. Okay? If you have any questions on that, send me an email, call me, do whatever you need to, and I'll help you work through it. Okay? Here is another example of a question that we have. It says an altitude makes 3 similar triangles. Find x. Don't get lazy. I'm going to say something that I say often and something that's very, very important. Take the time it takes, so in the end it takes less time. Okay? So take the time it takes, so in the end it takes less time. So what I'm going to do is I'm going to trace my 3 triangles. I used a different color for each. It might be handy if you got out a set of colored pencils to do your homework tonight, and to make 3 separate triangles. So I got 1, 2, 3. orange and a purple and a red. And what I'm going to do is I'm going to begin setting them up. And you know what? Last time, what I did was I kind of labeled them as small, medium, and large for each one. This time I'm going to kind of give like a value to each part. And so we can, as we go, because we already determined the small, medium, and large. So I've got X and 6. If that's 6, wouldn't from here to here, that section of the purple triangle, the medium side of the, wouldn't that be 26? If the whole thing is 32, and that little part is 6, because 32 minus 6 is 26. And so this is X. Let's call this H. H for height, because it's based on the altitude of, and so I just used, I guess I could use A, but I chose H in this particular problem for height. And then let's call this side Y. All right, so now I've got a value for everything. So I got 3 triangles. I'm going to color code them. I've got the medium one. Purple was just the color that popped up first for me. That's why there's no reason why I did the purple one first. So on the purple one, what's the smallest side? If you look at the diagram, you should be able to tell that the smallest side is H. The medium side is 26. And we called the longest side of that purple triangle Y. I know it's inverted, and that's going to end up, because something has to be inverted. The way you look at it in order to get the same small, medium, and long to all match up, you've got to kind of change the orientation of each triangle. So hopefully that kind of helps you. So now the color comes up next. Orange. I'm going to do the small triangle. And what's the small side of the small right proportional triangle? I believe that it's 6. Actually, I don't believe. I know that it's 6. And the medium side is H. And the longest side is X. Now let's look at the largest triangle. So we gotta go with red this time. So on the red, if you're just kind of looking at that red triangle, I believe the smallest side you got is X. The medium side of that, you got to be careful because the 32 and the Y are very, very similar. But if you pay attention to where that right angle on that triangle is, that'll tell you which one's the longest side, because the longest side is always opposite that right angle. So it's going to be 32. And the medium side is Y. Okay, so with all of this stuff, I can begin to see a geometric mean. Actually, I see a couple of opportunities for a geometric mean that we could work out. We could find every single value in here if I wanted to. But I see same sides with an X, same side with an X. So again, I'm going to say image over the pre-image as a proportion. So in the image, I've got 32 as to the pre-image is X. And then I have on the image, it's X is to 6. I hope you can see that from looking at the diagram, and that can help you. I got 32 is to X as X is to 6, setting up the proportion. So now I'm going to cross multiply. And when I cross multiply, we get 32 is to 6, or 192. So 32 times 6 is 192. And x times x is x squared. So my solution would be x equals the square root of 192. And if I want, actually I really want to set up my reduce that, I could say 192 is 64 times 3. The 6 is 8 times 8, and the 3. So if I factored that down, I have a pair of 8s there. So my answer, my simplified answer could be x root 3. Or if I wanted to take and just type it in my calculator, square root of 192, I get x equals 13.86. So that's the approximate answer. That's the exact reduced answer. And that's just kind of the square root, the exact answer. Again, whichever answer you feel comfortable, I'll be okay with. The one you're going to find the most often in your textbook, unless there's a decimal in the question, that answer right there. Okay, I'd like you to be familiar with all of those. Again, here's another example of a geometric mean. This is the last slide, so we'll work at this one too. Let's set up 3 triangles, just like we have on all the rest. I have a small triangle. Doesn't matter which color is which. I'm just pulling up whichever color comes first. There's a purple triangle. And then there's a green triangle. And then we're gonna create our last triangle, which is a red triangle. So that's this triangle right here. And so you got purple, green, and red. So now what we're gonna do is we're gonna make our purple triangle, our green triangle, our medium-sized triangle, and our large triangle. And this lesson has been one for, I've been doing this for years. And this one tends to be a little bit tricky homework assignment for some students. You want to know what makes the biggest difference? They'll come and say, Mr. Wilson, I don't get this geometric mean stuff. I'm trying to set it up and I just don't get it. And so the first thing I say is, all right, get out your colored pencils, take the time, and it's just like as soon as they get out their colored pencils, they start drawing the triangles, and then they start plugging in the values that's needed. It makes perfect sense to them, and they are all capable. I've never had somebody that when they begin to work through this, they didn't begin to get it. The real difference maker is are you going to try and rush this and try doing it without making the 3 different triangles, or are you going to take the time it takes so in the end it takes less time? So we got the altitude, or A. I'll call it A this time. Last time I called it H. And then we're going to call this side over here, we called it Y last time. Let's call it Z this time. All right. So as I look at this, on the purple triangle, the smallest side is 5. The medium side is A. And the longest side is Z. On the medium triangle, the smallest side is A. The medium side is 11. And the longest side is X. And on the large triangle, the short side is Z. The medium side is X. And the longest side, you got to add 11 and 5 to get 16. Now I'm just looking over my work. ZX16, A11X, and A5Z. In this problem, you can see again, X is going to be the geometric mean. X will be your geometric mean. So we'll again do the same thing. Image over pre-image. So in the case of the longest side, we have 16 is to X as, and on the medium side, it's X is to 11. So it's 16, the longest side on the biggest triangle, is proportional to X, the longest side on the biggest triangle, as X, the medium side on the biggest triangle, is proportional to 11, the medium side on the medium triangle. That sets up a geometric mean. We cross multiply, and we'll get 16 times 11 equals X squared. 16 times 11 is equal to 176 equals X squared. So you take the square root, and you'll get X equals the square root of 176. And 176 factors to 16 times 11. And you say, how do you know that, Mr. Wilson? Well, we already did that math up here. 16 times 11. And then if we factor that farther, 4 times 4 times 11. We could keep going and prime factor it, but I also already have a pair of 4s, and I know 11 is prime. So it's going to be X equals 4 root 11. So I have an exact answer. I have an exact reduced answer. I could also plug that into my calculator, and I get X equals 13.266. So that's the approximate, and that's the exact reduced. All right. Hopefully you got that. Again, you got any questions? Don't feel scared. You can reach out, and I'll answer any questions you have. All right. Here's your homework. This is the normal homework I have. I'm trying to make sure that I give you guys a little bit less homework than we normally would, just with the craziness. And on some previous lessons, I'd already chosen which ones I was going to do. I'm sorry, I hadn't done this before I started the video, but I'm not going to restart it just so I can pick the homework. Let's look here. I had 12, 13, 14, 15 homework assignments. So let's cut that down to 8. Let's go with numbers. Sorry, I'm just trying to decide which ones I'd like you to do. Let's go with 1 to 3. Numbers 8 and 9. So there's 5. And numbers 20 and 21. So I know that's only 7, but we'll go with that. We'll go with that. Yep, for 2020, let's change the homework to what I've got.